On this episode of Pathways to Wellbeing, Tom Malterre, clinical educator and co-founder of Whole Life Nutrition, explains the biochemical impacts of endocrine disrupting chemicals and shares his insights on how nutrition and lifestyle can support the body's biotransformation pathways and reduce total toxic burden.
If you are in a constant state of stress and you are worried about your toxins all the time, or you're not getting enough sleep, or you're not getting enough exercise, or whatever the case may be, it's tough for your body to say, it's now time for me to deal with all these, pollutants, right? So I love that. That you would think, let's get a person into a state of being happy, being engaged with their life, being, well fed and well slept and well hydrated, because in that state, the body will say, oh, I got everything I need. Let's take care of business now.
In the modern world, toxicant exposure is ubiquitous, with some studies reporting the average person is exposed to hundreds of environmental chemicals daily via air, water, soil, and food. While these exposures usually occur at a low level, the bioaccumulation of toxins in the body can be a root cause of several types of dysfunction. We certainly have so much to talk about. Welcome, Tom.
Hey, Clea, it's so great to be here. Nice to see you again.
Very good to see you. This is such an important conversation and one that I have with patients all the time. And it's always this nuanced conversation because we know that, every day we're exposed to these unseen toxicants and these chemicals, and it can seem a bit doom and gloom on the surface, right? It can seem a little bit scary.
For sure.
To start our conversation today, by emphasizing that part of our normal biological function is really to process and eliminate toxins, that our body is wise and it has the capability to transform some of these things. So just give us some insight about how you frame this conversation when you decide with your patient, we're going to go there. We're going to talk toxicants.
Really, toxicants are a word that is based on an assumption that there are things in our environment that can harm us. And when we really start talking to our clients and we say, oh, you have a disease, right? What causes the state of disease? Well, the dis-ease state comes from a person having too many things they don't need and not enough things that they do. So in my practice as a nutritionist, one who nourishes, I'm always talking about the things that can build you up, right? Whether it's the amino acids or the sulforaphane coming from cruciferous vegetables or whatever it might be, right? But many of us are forgetting that the reason that we're feeling lousy isn't necessarily just because we're missing the good things. It's also because we're bombarded with things that slow us down. We're bombarded with chemicals and EMFs that counteract some of our normal ability to be bright and intuitive and whatnot. They counteract our mitochondrial function, which would allow us to have vital energy and be, Johnny on the spot all day long, right? So I oftentimes will bring that in the beginning appointment. Actually, I'll just say, look, this is disease, right? And that's Dr. Sidney Baker, right? He's the one who is always telling us, he says, look, you have to diminish the things that don't serve you, increase the things that do serve you. So immediately I start talking about light as being a potential toxin. I talk about air pollution as being a potential toxin. I talk about the plasticizing agents that might be in people's hand lotions or fragrances, especially if they wear the fragrance into the office. And I'll give them an educational speaking to, if you will, about that immediately. So yes, automatically, I'll start stating to this person, you are what you are breathing, what you are thinking, what you are eating, what you are drinking, and what you cannot process. It becomes you. So if you are drinking fluids that contain certain chemical substances, or if you're breathing air, right, 11,000 cubic square feet per day, or if you're eating foods, then you have to think that those things will become you. And if you're suffering because of these symptoms of toxicity, things like fatigue, for example, or obesity, for example, then I will immediately point out the connection between the symptom and the cause of the symptom, which may be, in this case, a toxicant.
Well, of course, I love that you brought up it's what you eat and breathe and drink. So
Yeah.
think, right? It's this constellation of exposures from all planes of existence. So I think that's beautifully said. One thing I find is that we're often doing a analysis of our patient or our client's chemical exposures kind of later on in the process, like our initial treatment wasn't successful. And now we're thinking, okay, what's next? We got to keep this investigation going. But maybe that's not actually the best path forward. And I'd love to hear your perspective. Yeah. When is the right time to start thinking about these potential exposures?
Well, one of the most amazing things that I get to do as a nutritionist, right, one who is constantly thinking about what's coming into a person's body, is I do an intake, right? But I don't just do a written intake. I do a verbal intake of a person as they step into the office, and I'll say, "Hi, who are you? Great, let's introduce each other. Tell me about yourself. Tell me when it is you're waking. Tell me what it is you do first thing in the morning. Tell me what it is you do after that, and after that, and after that, and that. And tell me what sets you down on your bed in the evening and how long it takes for you to find sleep." And I learned about everything in between. So during that process, what do I get to learn about? I get to learn about that cup of coffee that came from the Keurig machine that had a piece of plastic that was wrapped in this, most likely conventionally grown coffee that has lots of pesticide residues on it. And then that plasticizing agent that got melted away to be put into that cup, right? And that cup, where did it come from? Well, it came from a dishwasher. Where did that dishwasher have exposures? Well, it was the actual detergent that went into the dishwasher that had some sort of fragrance agent and some sort of cleansing solvent agent in it. So I think about all these things the entire time, and I will bring these things up to the client when I notice there's an association. So for example, if I've got a client and this client says to me, "Yes, I've been dealing with obesity for the last 10 years. Oh, great. Okay. What are you doing on a daily basis? Well, I'm waking up, I do this coffee, I do these eggs, I do this, and I go to work. Where are you going to work? I work at a gas station. Oh, you work at a gas station. Yeah. What do you do at the gas station? I'm behind the counter all day long and I'm checking people out. And I'm thinking to myself, okay, great. So the gas station person is going to be handing receipts to somebody all day long. They're going to be opening and closing this door. They're going to be cleaning the outside, changing the window washing detergents at the same time, inhaling all the exhaust from the gas, right? So all these things are going through my mind and I'm thinking, what's your primary concern? Type 2 diabetes and obesity. Are there any associative data that would point me towards saying that your lifestyle may be contributing towards your disease? Absolutely. Come on. Back in, I love the studies that were coming out of Fred von Saal, right? He was talking about the receipt paper and how receipts themselves have a dusting of bisphenol A, right? Which is a monomer, a basic building block of plastics that coats the receipts, right? And the receipts themselves then have little pins that come in with heat. And the little pins, when they activate the BPA will release a dye, which allows the receipt to then print out the numbers and letters that you see on the receipt. But the BPA is not stuck on there. It's not via an adhesive. It's kind of just resting on top. And every time a person brushes against that receipt paper, then that BPA can get into their skin. And we see from Fred von Saal and other people's work that when that skin has some sort of penetration in it, that the level of BPA that can pass through the skin and then actually ultimately into the circulation increases over 100-fold, right? So you have a person who's constantly exposing themselves to a plasticizing agent, aka BPA, that now can increase the body weight of that particular human. So in order to get into that discussion, do you want me to jump into what an endocrine disrupting chemical is?
Let's do it. And I'll just pause for a moment to tell you, I heard you say that about the receipts, I don't know, maybe 5 years ago. And I've thought about it all the time. And I've never been more grateful for the option when they say, "Do you want me to email your receipt?" Yes, please. I would like that. Yes. So please tell us, what is an endocrine disrupting chemical?
Yeah. So in essence, I'm going to try and repeat the eloquence of my people that I admire, Pete Myers, for example, and Fred von Saal and Theo Colburn, who kind of made that term, I would say, well-known internationally. In that endocrine disrupting, so hormone disrupting, hormone-like substance, a substance that can travel into the human body and mimic what our natural hormones do. So let's back up a little bit and talk about what a hormone is. A hormone is usually produced in one area, gland, tissue, and will travel to another one and change the gene expression in that cell, right? So the cells make up tissues make up organ systems, right? So it will shift the actual gene expression. What does that mean? Well, that means that when your cell gets a signal from the outside environment to do something, to build in a protein from amino acids that would turn into an enzyme like glutathione transferase. Well, that signal came from somewhere. The cell just doesn't, willy-nilly, well, whenever it wants, it's going to start producing proteins. No, it waits to receive signals from the environment. And those signals most often come from either hormones or hormone-like substances. And the hormone-like substances can be chemicals that are in our environment. So I was just talking about bisphenol A. Bisphenol A is a monomer. We know it as a substance in plastics, but really a monomer, when you put a bunch of chains together, it becomes a polymer, and that becomes, polycarbonate plastics, for example. Well, thank goodness we don't use polycarbonate bottles as much anymore, but we used to. And as these things break down, those individual monomers, that BPA can be released. Well, so few people understand that, BPA originally was synthesized in 1891, and then in the 1930s, it was used as a synthetic estrogen. Before it was ever used as a monomer to build polycarbonate plastics, it was used as a synthetic estrogen. It was added into animal feed to fatten the animals. So let that one brew for a second. We now have this substance that's a $20 billion plus industry with 12 million plus pounds per year being produced all the time. And this hormone now is ubiquitous. It's all over the planet. It's in the soil, it's in the air, it's in the water, it's everywhere. And we get extremely high amounts in certain exposures. One of the highest amounts on planet Earth are these receipts, because it takes a big washing, a big, I would say, layer of this BPA that's not adhered to anything. It's kind of just resting on there, and it can easily slough off and then get into a person's system. Now, we know of estrogens. We know that estrogens work at minute levels, right? Picogram levels. Picogram versus pounds, millions of pounds, 12 million pounds being produced every year. That's enough to spread teeny picogram levels all across the globe, right? So we're seeing this accumulation happening everywhere. Now, hormones in the human body, estrogen and whatnot, will work on the picogram level. So you get these small level of plastics. If the plastic is a nanoparticle, for example, can be absorbed actually through the skin, travel into the person, go around in the blood. It's not like a standard toxin per se. A standard toxin, you say, like, I don't know, mercury or cyanide or whatnot, you get a certain level of this. Mercury is a poor example because it's pretty toxic at any level, but cyanide, you have to get the cyanide levels to a certain point. You get a certain amount of damage in the cell, and then you notice the symptomology, right? Well, hormones work at minute levels all the time. There is no real safe level. You get a small amount of hormone, it's going to have an effect. And what we're finding with some of these plasticizing or petroleum-based hormone-mimicking substances is they behave like hormones, but they don't get treated like hormones. Meaning you have a substance in your body called sex hormone binding globulin that would normally grab onto normal hormones that you make and get them out of the system so you would not have cellular activity and gene changes. But in some of these plasticizing agents, that's not the case. And some of the cases is that sex hormone binding globulin will not bind to it. So it will have unchecked hormonal response. So you have to be cautious. Teeny amounts make huge effects. So hormones, one of the things I want to think about is, when I should call him Dr. Professor Seralini, Gilles-Eric Seralini from France, he's the guy who was, all about the GMOs. I don't know if you know him, but he found or discovered the aromatase enzyme, okay, a cytochrome P450 enzyme. And what he noticed is that the aromatic compounds from petroleum, these benzene rings that BPA and other petroleum-based compounds are made of, were originally compounds used by plants to communicate reproduction and growth. So they might have been a smell, or they might have been a plant hormone of sorts. But when they got squished down and they got turned into petroleum over time, and somebody removed them from deep within the earth and burnt them and treated them with solvent chemicals, they now had what looked like normal hormone compounds that had been disfigured. And these disfigured now hormone compounds will act as hormones. They'll say, like, where am I supposed to go within a plant or within a human or whatever? How am I supposed to change reproduction? How am I supposed to change growth? How am I supposed to change cell communication? How? Well, it can't because it's in the wrong shape now. But it passes into all these areas where it should be able to do its job, but it doesn't anymore. It's miscommunication. So as Professor Ciarlini says, he says, hey, Tom, these are molecules of love, right? They're supposed to be turning on the mitochondria, so the mitochondria is functional, turning on the sex organs, so we have more estrogen and we have more testosterone and we have more reproduction and we have life and we have everything. But unfortunately, now that they're the wrong chemical structure, right, we have the opposite. We have obesity. When the sperm is trying to divide, it cannot do that quite readily. And so we end up with disfigured sperm or non-motile sperm, right? And so we're guessing by the year 2025, we're going to have a drastic decrease in actual virile men on planet Earth, right? So all these endocrine disrupting compounds, these hormone disrupting compounds are basically disrupting life itself, life communication, cell communication, reproduction.
That was a very profound tour through the history of endocrine disrupting chemicals, but I think really importantly highlights what outcomes we're looking at. And it's fascinating to hear you talk about how, we've known for some time that these chemicals can potentially interact with our hormonal and metabolic systems, but I think it's more contemporary that we're really starting to think about, well, how are these relating to chronic disease? You've mentioned a few things: diabetes, obesity, infertility. Are there any other conditions we should be thinking about that have a suspected relationship with endocrine disrupting chemical exposure?
Absolutely. When it comes to fertility, right, there's a lot of division that occurs. Right? So if you're making a sperm, or once the sperm, fertilizes an egg, there's a tremendous amount of reproduction that occurs. And anytime that you have a template of something and you're wanting to pull a piece of that template out and mimic it, and pull another template out and mimic it and pull it out, there's always a chance for errors. And what we're finding is when we have specific chemical substances around, the tools that we use to read our genes and how we reproduce are completely shifted. And so we're finding a lot more birth defects. We're finding a lot more miscarriages. We're finding a lot more, I would say, predispositions for disease that are occurring in the developmental process of newborns. So that piece is unsettling. And one of the things Pete Myers taught me, for example, is he said, Tom, you hear of these things as obesogens, but do you even understand what that means? And I was like, well, yeah, isn't that later on, and insulin is increased by BPA and, all these things are happening. He's like, no, this is developmental. He says, you may have, this pluripotent stem cell, and this pluripotent stem cell wants to become, an osteocyte, a bone cell, for example. And he says, if it receives this chemical signal from some of these endocrine disrupting things early on, it'll become a fat cell. So you'll actually end up with lower amounts of bone cells and higher amounts of fat cells. It's like, wow, how does it even happen? He's like, it's in the beginning. We receive signals all the time to tell our genes what needs to be read, what becomes what. Is this going to grow? Is this protein going to be made? Is this fatty acid? What's going to happen? How is it going to interact? All of it comes from signals. So if we disrupt the signaling, we disrupt the outcome. I thought that was fascinating. So there's that. And then one of the things is, if you have excessive growth or uncontrolled growth, or not an ability to turn off growth with certain proteins or tumor suppressive proteins, then we'll end up with more cancer. So we're seeing a lot of cancers. And you've heard of things called estrogen positive cancers, for example. Well, I've had clients that, due to their lifestyle or their profession, they're either in the field of plastics or something that's associated with plastics, they'll come into me in their mid to early 20s and they'll say, hey, I'm on my 6th round of breast cancer. And you're like, how is that even possible? And then you figure out through their work, they're constantly exposed to these plasticizing agents. And these are now what would be considered estrogen positive or estrogen promoting agents. And so it starts making sense. We're turning on that growth, process in those cells, and therefore we're having unchecked regulation. So yes, I would consider cancer as one of those as well.
Yeah, this is where I start to get a little fired up about functional medicine, because, you described the preconception considerations and potential maternal exposures and how that can affect the health trajectory of the offspring. And wow, aren't we uniquely suited to do that investigation because we already consider the timeline of someone's life, and we look at their preconception timeline, and we look at their mother. And so, wow, like how wonderful that we're able to capture those.
Exactly.
And we'll talk a little bit more about, what we're going to do. And so I think this is a really important part of the conversation where we can say, yes, you have all of these predispositions. Now, what are we going to do about it? Right.
Yeah. Yep, that's exactly right. And, it's interesting, right? So some of my clients, we've tracked back miscarriages or birth defects or neuropsychiatric issues in the children to the father being a fisherman who was, working with a lot of lead weights or, on the fishing lines. Or we've determined it back to, a person who's been working in a oil refinery, for example. They've been exposed to a lot of gasoline adducts and whatnot. So yes, I mean, that makes sense that we would dive all the way back to the beginning before things even happened, what's going on with mom and dad. And if we were to look at it really, and you look at the data on endocrine disrupting hormones or endocrine disrupting chemicals, I should say, they're multi-generational. So sometimes you've got 3 or 4 generations back where you'll see the exposure, and that might have predisposed the next generations to these issues.
Yeah, sure thing. Thank you for that. I have some questions about, what we will actually do in terms of treatment and lifestyle interventions. But before we move there, I just want to ask one more follow-up question. Do you find that in asking about your patient or your clients' modifiable lifestyle factors, that's kind of one of the pillars of functional medicine, is that we're checking in on nutrition and sleep and exercise and relationships. And in doing so, we kind of figure out what people do for their job and what kind of foods they're eating and what, are they sweating, those types of things. From my experience, you're able to gather quite a bit of information about someone's toxic exposures just from asking their lifestyle questions. Is that something you found to be true as well?
Oh, absolutely. That's why I was mentioning that, that day schedule, right? What time are you waking? What are you eating? What is going on throughout the day? You'll see it all right there. And immediately as a functional medicine trained practitioner, I'm clicking, writing down these important things on a piece of paper. And I'm saying, holy smokes, look at the plastic exposure. Oh my gosh, look at the flame retardants. This is an airline person, they're going to be exposed to pesticides and flame retardants. Oh my gosh, this is it just throughout the day unfolds. Absolutely. And then I'll also look at the behaviors that might increase the detoxification. So as you had said, sleep is probably one of the most important things across the board for general health, let alone for detox. But if there's not enough sleep, there's usually not enough mitochondrial function, and detox is very energy hungry. Then I'll look at the actual nutrient density. And in order to diminish your load of toxins, whether it's a plasticizing agent or whether it's a heavy metal, whatnot, you're familiar with phase 2, right? What is phase 2? Phase 2 of detox is conjugation. Conjugation means to mate. It means to bind something to something else, change its shape and change its behavior, right? Well, the conjugative process actually attaches your glutathione or your glucuronide or your sulfate or your acetyl group or whatever it's going to be. And once you attach it, then that is excreted with the toxin. So if you have solvents, for example, that person will be glycine deficient. Why? Because they're clearing the solvents with the glycine. If that person's heavy metal issued, it's going to be the glutathione or it's going to be the chelative agent, whatever it is going to be deficient, right? Or in the case of plastics, for example, it's going to be the glucuronide. The glucuronide will diminish. So how do we increase the glucuronide, right? So you start thinking about the therapies for that.
Wow. I love that you're bringing us back to this concept that you introduced in the beginning of it's not just getting rid of things, it's also kind of repleting what you're deficient in, because it's a delicate balance.
Absolutely. Everything's a delicate balance, right? So yeah, I'm always thinking, what are we doing to increase what we need while we're decreasing what we don't need, right? So the things that we need to clear the toxins, the things we don't need, are going to be some of those nutritive support systems. Yeah.
Yeah, very interesting. I know that your clinical background, that you really focus on nutrition to support these biotransformation pathways. And I'd love to hear from you. Are there certain dietary patterns that you find make it more difficult for people to biotransform?
Well, that's a tough one.
Loaded question for sure.
Yeah, for sure. And it's an interesting piece, right? Because we're not really sure what's going to happen with a lot of these carnivorous, fat-associative keto diets that are maybe not necessarily ingesting the most clean foods, possible. There are people who are doing incredibly immaculate, keto-based, fat-based diets or carnivore diets, which is great. And there are others who are not. They're consuming, conventionally grown meats, and they're exposing themselves to a high level of pesticides or the chemicals associated with those pesticides. And those people, I'm a little concerned because hormone-associated disorders don't usually manifest themselves over a year or two or whatnot. They usually manifest over about a third of an animal's lifetime, if you look at the research. So if you're looking at a human, what are we talking about? 13, 14 years, is when we might see, that kind of manifestation. So if a person is on a dietary trajectory and they're not familiar with the level of potential toxins that might be coming in on those fat-based products, for example, we won't see those results. We won't see that autoimmunity. We won't necessarily see the weight shift changes like earlier, but you may not see it until later on, right? So I don't know yet. I mean, in the early stages, things look great on some of these, what would be considered modern or alternative diets, whether it's the carnivorous or the, ketogenic type diets. I would just say that as a person who knows that you are what you ingest and cannot process, that I would be very cautious about where my food is sourced from. And I would do everything I possibly could to support a clean environment. So not only my food, but my children and my family and whatnot and friends are all in a very clean environment as well. So that's a tough question. I'm not sure I can answer that yet to know. I do know that if a person is consuming vegetables, and there's arguments now about oxalate levels and all sorts of different chemical byproducts of foods, the plant protective chemicals is what we call them. Those may be potentially harmful in a minor sense, but may trump with the importance of having lots of polyphenolic compounds or glucosinolate compounds that may negate some of these harmful effects. What do I mean by that? Well, we'll take broccoli, for example. And the glucosinolates in broccoli. So we commonly think of sulforaphane, right? Glucosinolate is a thiocyanate, a thiol, a sulfur compound connected to glucose, right? So we cleave the glucose and we have this sulforaphane. And that sulforaphane is a hormone-like substance. That sulforaphane travels into the cell and will bind to a repressor type complex, allowing for the freeing of something that can read genes very well for both detoxification and antioxidant function. So if we have plenty of this sulforaphane compound around, what do? We turn on glutathione transferase. We turn on UDP, glucuronidyltransferase. We turn on the things that actually accelerate the detoxification of some of these harmful substances. So while we're over here saying, watch out for BPA. Watch out for flame retardants. Watch for these estrogenic type compounds that turn on genes. We're also over here saying, hey, look at these beneficial plant-based compounds that turn on beneficial genes, right? And what we're seeing is when you have some of these little counterplaying signals happening, some of them kind of trump others. So the cruciferous vegetables seem to be fantastic about regulating these hormone disrupting chemicals. Not only for the fact that they will change some of the effects of the chemicals, but they'll actually help with the discarding. So you'll actually be able to package these chemicals. You'll turn on certain genes like that UDP glucuronidyltransferase, and then you'll attach these glucuronides to all these plastic pieces, and then they will travel out through the bile and your intestinal tract and into the toilet. So yes, there's these negative signals, but the plants also have the positive signals.
What I'm hearing, I'll relate this to, in my practice, I see mostly fertility patients, and it can be anxiety producing when you're trying to get pregnant and people are so worried about any action that they're doing on any given day. And so we always have the conversation, it's probably less important, like little micro actions that you're doing on any given day and more how you're treating your body and nourishing your body on a daily basis over a long period of time. And it sounds like the same is true for supporting our biotransformation pathways, that it's really these lifestyle choices that we're making over long periods of time that's going to have some protection.
Oh, thank you for bringing that up. So we have to think of the environment always, like what environment, right? And the environment for detox in a human being has to be an environment of rest, digest, and detoxification. So rest, digest, detoxification comes from parasympathetic responses, not a sympathetic response, meaning the system is either engaged in fight or flight, trying to kick something out or combat something, or it's engaged in, I'm going to take the time to clean house. I'm going to look around. Is there something I need to repair? Is there something I need to break down, digest, and absorb? What is it, right? So if you are in a constant state of stress and you are worried about your toxins all the time, or you're not getting enough sleep, or you're not getting enough exercise, whatever the case may be, it's tough for your body to say, it's now time for me to deal with all these, pollutants, right? So I love that. I love that you would think, yeah, let's get a person into a state of being happy, being engaged with their life, being, well fed and well slept and well hydrated, because in that state, the body will say, oh, I got everything I need. Let's take care of business now,
Yes, perfect. You mentioned the role of plant-based compounds and turning on or off genes. And so I thought that was a good doorway to talk about genetics a little bit. Are there genetics involved in our ability to biotransform, or our susceptibility or our sensitivity to toxic exposures? And if so, what do we do with that? Are you using that kind of information in the clinic with, just a normal intake?
Yeah, for sure. So I have a unique relationship with my clients in that I work with physicians who order extensive testing. So I'm looking at gene analysis constantly. I'm looking at a nutrient analysis constantly. I'm looking at gut analysis constantly. And usually taking in, thousands of pieces of information from conventional alternative labs and putting a picture together about where this person is and what we can do to assist this person, right? So I will be looking at genetics oftentimes. And for example, plastics. If I see an issue with UGT, 1A128, for example, that is a glucuronide associated gene. Why am I concerned about that in plastics? Because the primary way we get rid of BPA is we attach a glucuronide to it. Well, what is it? 3 to 7% of the general population has something called Gilbert's. Well, Gilbert's is a deficiency of this specific gene. So have I noticed in my clinical practice that my Gilbert's clients are more sensitive to specific toxins in the environment? Absolutely. And we're starting to see now cancer associations between these gene SNPs and exposures, right? So I will say, all right, well, what can I do for that specific person? Well, once again, we'll go back to example I already used. The literature clearly shows if a person has these gene variants, they're diagnosed with Gilbert's, there are certain foods they can consume to upregulate those UGT or UDP glucuronidacetyltransferases, they're called enzymes. And we know that once again is the broccoli, cauliflower, cabbage, kale, Brussels sprouts, arugula, radishes, and my favorite is just the broccoli sprouts themselves, right? Broccoli sprouts seem to champion this. I mean, you can see people's bilirubin levels normalize when they've had a lifetime of Gilbert's just by adding in certain cruciferous vegetables. So sure, absolutely, we're looking at genes. And then there's, of course, the GST nulls, the people who can't do the glutathione transferase very well. Once again, they seem to also benefit from the cruciferous vegetables. I'm always taking into consideration the whole gamut. Look at the gut, for example. A person may have an overgrowth of gut bacteria that may be producing a lot of beta-glucuronidase. Well, what is that? That's the enzyme that cleaves that glucuronide. So somebody got exposed to plastics. They were handling receipts. They were eating, plastic lined canned foods, right? Or drinking out of polycarbonate bottles. And they got a high level of BPA. Fantastic. They're eating a lot of cruciferous vegetables. That's great. Cruciferous vegetables ramp up that enzyme function. Now the glucuronide is being formed more. It's binding to the plastics. Great. That's going in through the liver and the bile, coming out through the intestinal tract. And now once it's in the intestinal tract, all of a sudden they've got this overgrowth of bugs that are producing an enzyme, beta-glucuronidase, cleaves off the glucuronide. So darn it, we went through all that work, right? We're now getting this plastic out of here and this cleaving. No, so, well, we look at the gut and we say, well, can we add in, Rhamnosus GG or an acidophilus, or can we add in, Bifidobacterium bifidum, which has been real well researched to lower that level of beta-glucuronidase. So, there's a lot of places that we can intervene, and it's pretty much limitless based on the amount of information that you get.
I'm so glad that you've mentioned, in functional medicine, we talk about these areas of clinical imbalance, which is essentially a map of our body systems. And now I've heard you talk about our ability to, absorb and utilize our nutrients to help us biotransform, and our gut health in general, our cellular energy production and our mitochondrial health, and then our detox pathways in terms of genetics and the precursors that we have. Like, wow, the whole body is involved in this process, and we really can't isolate and say, your detox pathways. This is a full, all body systems on board.
Oh, absolutely. And we haven't even gotten into mitochondrial function, but my late great friend, Walter Crinnion, he said, Tom, every time I dive into chemicals, it doesn't matter what it is, whether it's metals or EDCs, the endocrine disrupting chemicals, every single one of them has an adverse effect on the mitochondria. So whether it's, the ETC, the electron transport chain, or somewhere in the Krebs cycle intermediates, he found some sort of diminishing effect of mitochondrial function, which, you start thinking about it and you're like, wait a second, every single chemical that you've been researching for, decades now, that's kind of disconcerting. I mean, back in 2010, right, our own Environmental Protection Agency did an inventory of chemicals that were being imported or produced in the United States. And at that time, it was 2010, mind you, it was 11 years ago, 2010. They found that there were 74 billion pounds of chemicals being imported or produced in the United States every single day. 74 billion pounds. Okay, that's 250 pounds per person per day at that time in 2010. Of course, we now have an increase of those sales of multiple different chemicals. So it's probably a lot more than that. And you start thinking to yourself, wait a second. So a lot of these chemicals can interrupt signaling of our body. A lot of these chemicals can interrupt the actual energy production within each and every single cell. So if that's the case, we have signaling and an energy deficit. Is there any reason why we wouldn't have people who have hormone problems these days, who have energy deficit problems, metabolism issues, whether that's blood sugar metabolism, whether that's, obesity, whether that's going to be some sort of manifestation of someone who's exhausted all the time and cannot signal their cells to function normally. So you begin to wonder, well, why wouldn't we be in a state of disease, right? We're all adapting to a modern environment that's laden full of toxins.
That's the perfect lead in to my last question as we're coming to the end of our episode.
Yeah.
You have so thoughtfully described how toxicants are interacting inside a human. But when we look at the bigger picture, you already talked about how microplastics especially are pretty ubiquitous all throughout our soil and our air. And thinking from an environmental perspective, what should we be thinking about in terms of the microplastics that might be found throughout our whole environment? Like, how's that affecting our food supply?
See, this is the part that's hard for people to swallow, right? Because what it comes back is to you. It comes back to your daily choices. So what are you doing? What are you doing for a lunch container that you're bringing to the office? Are you wrapping things in plastic bags? Are you purchasing products at the grocery store that are laden with plastic? Are you purchasing clothes that are, made of synthetic materials? Because if they're made of synthetic materials, what happens? You go and take the dryer lint out all the time, right? What is that? Microplastic fibers if it's a nylon-based product, right? So all these things end up in the air, they end up in the water, and they'll end up in the ocean. Now, here's something that I thought was fascinating. Pete Myers, what a genius. He says, if you look at the ocean, right, a lot of the toxicants, a lot of the petroleum-based byproducts, they will actually float to the surface of the ocean. And if you test the chemical levels of the top 1 inch of the ocean, you'll see 100,000 times higher levels of toxicants than you will 6 to 12 feet down from that, right? Why? Because fats float, lipids float, right? And a lot of these things are lipid-based toxicants. So if you're burning something environment, you get dioxins and furans, you'll float it at the top of that ocean. If you have something that's sunk to the bottom of the sea and it's a toxicant, it'll float back up, right? So what do you see with our dolphin populations? And what do you see with our killer whale populations, right? We're seeing them having all sorts of hormone reproduction issues, right? Because of the toxicants they have to breathe in all the time by going through that top 1 inch of the ocean, right? So your choices on a daily basis, what are you putting on your skin? What are you using for sunscreen lotion when you go into the ocean? They're affecting the entire food chain in the ocean. And then that food chain affects the food chain on the land. So it goes back and forth. I mean, we can never get away from it. It's as if we're trapped in a big terrarium. As a kid, we all had those little terrariums, right? And if you forgot to water it, or insects came in, or there was some little shift in the terrarium, the whole thing would fall apart. Well, we have to think, like, what are we doing in our terrarium? Like, on a daily basis, how am I choosing my coffee? How am I choosing my lotions? What's going on with my clothing, or anything that I'm deciding to bring into my environment? Because it's not just my environment, it's our environment. So it's just conscious consumption, I think.
That's great. You may have just answered my very final question, but as I said in the beginning of this episode, I think it can be somewhat overwhelming when we start to talk about all of the things we could be exposed to, right? Is there some final piece of optimism that you can leave our listeners with to leave them feeling empowered and enlightened and ready to make conscious choices?
Oh, absolutely. Well, the key thing is that we live in a capitalistic society still. And so as long as people are geniuses, which they are, and as long as they have a big heart, then we can solve a lot of things. I mean, there's some people growing specific types of fungi now, for example, and they're bringing plastics into these little tubes of fungi, and they're seeing how the fungi can actually digest and completely eliminate plastics. Is unheard of, because usually plastics do not break down. I mean, if you leave them in the environment, they will just get smaller and smaller and smaller, but they will never break down, right? Well, now we found substances, or we found living organisms that can utilize the structure of the plastics for their own well-being, right? So if we all just got creative, I mean, they're making plastics out of mushrooms, for example. There's a MacBook Pro that was made out of a mushroom plastic, and there's an entire Learjet that was made out of mushroom plastics, right? So if we allow the marketplace to start producing these things, and we demand them, we say, look, I will not consume these types of clothes. I will not consume these types of foods. I will not consume these types of packaging. Come up with another, solution. It may be a little bit more expensive in the short term, but in the long term, it's going to be well worth the investment. So I would say, get creative, folks. Get out in the marketplace and invent some cool stuff that's going to help the planet.
All right. Any of our innovators who are listening, you know what you need to do. That's fantastic. I certainly think that this conversation is so important, and it's always a delight to chat with you and to elevate this information so that it's more widely available. We know what we should be thinking about. Thank you so much for being with us and sharing your insights and your experience. So appreciate your time.
Absolutely. My pleasure.
To join the conversation on this topic, visit IFM's pages on Facebook and Instagram. For more information about functional medicine, visit ifm.org.